All right, so in this part of the video, we're just going to look at the parts for 11.1 to 11.3. So let's start with number 1. So number 1, it says if FST final last year was normally distributed with a mean score of 82 and a standard deviation of 3. So it says sketch a normal curve using the 68, 95, 99.7 rule. First off, can I just say that this is the best looking normal curve I've drawn all semester? And I got it first try. Anyhow, so what we're going to do is remember that when we're doing this, before we learned about how to convert things into their z-scores, we created this normal curve, and we always have in the middle here, we always have whatever the mean is. And so the mean is 82. And then the standard deviation tells us what scale to use. So the standard deviation is 3, so we're going to count by 3s. So this will be 85, 88, and 91. If we're going to go to the left of 82, we would subtract 3. So we'd have 79, 76, and 73. Now the instructions here tell us to label this using the 68, 90, or 68, 95, 99.7 rule. And so I'm just going to add a few lines here so we can see better where things are at. All right. So the 68%, remember, represents within 1 standard deviation of the mean, so this would be 68%. The 95% is within 2 standard deviations of the mean. And the 99.7% would be within 3 standard deviations of the mean. Now, if we wanted to, we could put some more numbers in here because we know that this segment between 0 and 1 standard deviations above the mean would be 34%. We know that this between 1 and 2 standard deviations above the mean would be 13.5%. And we know anything more than 2 standard deviations above the mean would be 2.5% of your data. And the same would be true in the other sections on the other side. All right, so now let's use this information to answer the question. It says, what percent of students scored between a 76 and 85? So 76 would be here, and 85 would be here. So we're going to add those all together. Now, I do recognize that this segment is 68%, and that this one here, so this would be 68, and the other segment there would be 13.5. So we're basically going to add 68 plus 13.5. When we do that, we get 81.5%. The next one, what percent of students got an A? That's an 88% or better. So that would be this much, which we know that's going to be 2.5%. So that's just a review of how to do, how to read a normal curve and how to set one up. So you want to make sure you know how to do that. All right, number 2. Number 2 is a review of a z-score. Remember, your formula for a z-score is this, where we take x minus the x bar and divide by the standard deviation. And the standard deviation, and they give us all that information here. They tell us that we're trying to find the z-score for a car that gets 35 miles per gallon on the highway when the average miles per gallon is 27 and standard deviation is 3.6. So x is your 35. Our x bar is our average, or your mean, which is 27. And our standard deviation is 3.6. When you do that on your calculator, you get 2.22 repeating as your answer. So as your z-score, we'll just round to 2.22. All right, for number 3, for parts A and B, this is where you could just use your graphing calculator and do that normal distribution, or that norm CDF button. So for this one, we do norm CDF, and then since we're trying to find the area of the shaded region, it goes infinitely to the left. There is no lower boundary. So we're just going to put a lower boundary like -9, and our upper boundary is the right side of that shaded region, which is -1.35. And some of your calculators, you need to do this other part with the 0 and 1. Some of your calculators, it's just asking for the lower bound and the upper bound. That's all you got to put in. But if you do have the operating system where you have to put in 0 and 1, make sure to do that. And when you do that, you get your answer, which is 0.0885. And the last one here, for part 3, or for number 3, again, we're going to do the normal CDF. Except for this time, our lower boundary is 0.89. Our upper boundary keeps going on infinitely. So we'll just say 9, and then 0 and 1, if you have to do it like mine. And then when you do that on your calculator, you get 0.1867 as your answer. For number 4, it says, suppose the age of those voting in the 2020 election followed a standard normal distribution, and the average age for someone who voted in the previous election was 52, with a standard deviation of 4.5. What percent of voters were between the ages of 40 and 55? Okay, so basically what we're doing here is, see, look at how bad that normal curve is. We're trying to find out what percent of voters were between 40 and 55. Okay, now, in order to do that, we need to convert that 40 and 55 to be z-scores. So we're going to start by finding the z-score for 40 and find the z-score for 55. So let's start with the 40. So the 40, we know that the average was 52, and the standard deviation was 4.5. So if I take 40 minus 52 divided by 4.5, I get negative 2.67. Okay, so that 40 has a z-score of negative 2.67. And now we're going to do the same thing for the other value, the 55. So we'll take 55 minus 52 divided by 4.5. Well, 55 minus 52 I know is 3. Divide that by 4.5, we get 0.67. So that 55 has a z-score of 0.67. So now when you do your norm CDF, we would do between negative 2, so our lower boundary is negative 2.67. Our upper boundary is 0.67. We'd have 0 and 1. And when you do that, you get your answer of 0.7448. Now the key here, it says what percent. So we're going to do that as a percent, which would be 74.48%. All right, so that is the review from those 3 sections we did in Chapter 11.